Hi everyone, welcome to my YouTube channel. So today I'm going to discuss physics syllabus of UPSC CSE optional. But I must say that if you are in your BSc, specifically in BSc honors or MSc, okay, these videos are going to be helpful for you people also. So I'm going to discuss here two papers. Hope you know that in UPSC you have to give two papers of physics. One is physics paper 1 and physics paper 2. So what does physics paper 1 comprise? It comprises of classical mechanics, electromagnetism, electromagnetic theory, you have wave optics, wave oscillation optics and all, and you have thermodynamics and statistical mechanics. Okay, so paper 2 much easier than the above: quantum mechanics, atomic and molecular physics, followed by nuclear physics and solid state physics and electronics. Okay, so 4 papers officially and 5 papers here because it has another part, the electromagnetic theory, and we'll discuss it in a moment. So let's go to the next slide. So let's see the physics paper 1, the syllabus of physics paper 1. We have mechanics of particles, mechanics of rigid bodies, mechanics of continuous mass media, and special theory of relativity. So we have the laws of motion, conservation of energy and momentum, applications to rotating frame, that centripetal and Coriolis accelerations, motion under a central force, conservation of angular momentum, Kepler's law, fields and potentials, gravitational field and potential due to spherical bodies, Gauss and Poisson's equations, gravitational self-energy, two-body problems, reduced mass, Rutherford scattering, center of mass and laboratory frame of references. Followed by the rigid body motion, system of particles, COM, center of mass, angular momentum, equations of motion, conservation theorems for energy, momentum and angular momentum, elastic and inelastic collisions, we have rigid body, degrees of freedom, Euler's theorem, angular velocity, angular momentum, moments of inertia, very important part, theorems of parallel and perpendicular axis, and we have equation of motion for rotation, molecular rotations as rigid bodies, di and triatomic molecules, we have precisional motion, top gyroscope. Okay, we're going to cover this. Now we have mechanics of continuous media, elasticity, Hooke's law and elastic constants for isotropic solids, and the interrelation, streamline flow, we have the fluid mechanics, viscosity, Poisson's equation, Bernoulli's equation, Stokes law and applications, followed by the special theory of relativity, which is very important. We have Michelson-Morley experiment that gives the disapproval of the principle of ether, the presence of ether and its implications, Lorentz transformations, length contraction, time dilation, very basic things, addition of relativistic velocities, aberration and Doppler effect. We have mass energy relation, both with momentum and all. So we'll see this obviously. We have simple applications to a decay process. We have 4D. This is an advanced part. 4D momentum vector, covariance and equations of physics. So if somebody is able to master in this part, physics is going to be easier for him or her. Okay. So classical mechanics, obviously the toughest part of physics, we'll obviously cover it. So let's go to the next slide. We have waves and optics. First we have waves, very basic things of SHM, damped oscillation, forced oscillation. We have resonance, beats, stationary waves. For stationary waves, like this and this, we have done an experiment in lab during our undergrad, and Mendel's experiment, or what's the name, I don't remember. So we have this, we'll see these things. We have phase and group velocities, reflection and refraction from Huygens principle. Okay, this should be here, whatever. So Huygens principle, we just need to prove the laws of reflection and refraction. So thanks to UPSC for mentioning it. Then we have geometrical optics, In UPSC syllabus, this I or C is missing in official site. I was amazed that UPSC is also doing this kind of mistakes. So we have laws of reflection and refraction from Fermat's principle. So good. We have matrix method in parallaxial optic thin lens formula. Nodal plane system of two thin lenses, chromatic and spherical aberrations. Okay, we'll do this portion. We have interference of light, Young's double slit experiment, Newton's ring, interference by thin films. Some problems will come from this part, important. Michelson interferometer, that will be covered in classical mechanics as well, while we'll study the special theory of relativity, Michelson-Morley experiment. Obviously we need to know the principle of Michelson interferometer in that case also. We have multiple beam interference and Fabry-Perot interferometer. Their explanation, the diagrams are very important for the point of view of the examination. We have Fraunhofer diffraction and Fresnel diffraction. For Fraunhofer we have obviously single slit, double slit, that intensity formulas and all, the resolving power, the grating, diffraction by a circular aperture and array pattern. We have this kind of patterns. We'll read this. Half period zone, zone plates and circular aperture. So we have another portion. Okay, this is a big portion a little bit, but we don't need to go to details except polarization. We'll read polarization in a little bit detail, followed by we have optical fiber. This I haven't studied in my BSc. I think I have done an experiment in lab of optical fiber. So yeah, not in BSc, but I have done in MSc, I think so. Now we have laser, very basics of laser like ruby and helium, the Einstein's coefficient, some complex kind of mathematics, not so complex, but okay, we'll see that. Tree level laser, we have spatial and temporal coherence, a very important mechanism for the lasing action. Okay, so and last we have holography. So this portion is divided into 4 parts, so this will take a little bit time, modern optics, so we'll do it. Now let's go to electricity and magnetism. We have electrostatics and magnetostatics. We'll do this from Griffith or some other book. You can use any book. Okay, whatever in which book you are understanding, you should follow that book first, then you should go to standard book, because it is not possible for a beginner to begin with Griffith. People say begin with Griffith. If you are a normal student, normal means okay, everybody is a normal student, so if I don't recommend to start with Griffith. First read some basic book, then go to Griffith. Griffith is an excellent masterpiece, no doubt in that. Okay, so Laplace and Poisson equations and electrostatics and applications, energy of a system of charges, multiple expansion of scalar potential. We have methoded images and applications, potential and field due to a dipole, force and torque on a dipole in an external field. We have dielectrics, polarization, solutions to BVV problems. Like this kind of problems will be given. You have one sphere, this potential will be given, this potential will be given, potential in the middle you have to find. So for that case you have to use this Laplace equation, Poisson equation as per the problem given. Okay, we have ferromagnetic materials, hysteresis, energy loss. Such kind of diagrams will read for iron and steel. Okay, comparison. I think such questions had already occurred in the examination, so it's a very common question. Now we have current electricity, Kirchhoff's law, obviously not that class 12 level formula. Here we will use complex number for this Kirchhoff's law and their applications. We have Biot-Savart's law, Ampere's law. Okay, all in terms of Del, nebula, whatever you say. We'll see that. We'll see Faraday's law, self and mutual inductances, mean and RMS values in AC circuits, DC and AC circuits with LCR components, both parallel and series. Obviously we have quality factor Q. We have the principle of transformer. Okay, so basic things, and transformer is a very common thing. Maybe we can be asked to draw the circuit diagram of a transformer, the basic principle and all, so Diagram should be done very well for this examination. Diagrams, introduction, conclusion, the body part. This is the main thing examiners are checking in you. They are not checking your scientific temperament. For this exam, I must say, they are checking the writing quality. The quality as an officer you must give to this country, for this nation. Okay, so that is important. So now let's go to electromagnetic waves and black body radiation. We have displacement current and Maxwell's equation, wave equation in vacuum Poynting theorem, scalar and vector potentials, electromagnetic field tensor covariance, Maxwell equations, wave equations in isotopic reflection, diffraction and boundary of two electrons. This will take a good amount of time to understand. Not so tough, so okay, हो जाएगा, no problem. Franz's relation, total internal reflection, normal and anomalous dispersion, Rayleigh scattering. Now this is a part of actually your quantum mechanics, or you can say statistical mechanics, but they have included, okay, they have included here, no, black body radiation. So black body radiation is an important part. We have the Planck's radiation law, Stephen Boltzmann law, like this. We're going to see some of these graphs. This is Planck equation, this is Rayleigh Jeans, Wayne's. We'll see this ultraviolet catastrophe, everything. Okay, now let's see the fifth portion, the last portion of paper 1. We have thermodynamics and statistical mechanics in this part. First we have the laws of thermodynamics, first law, second law, and obvious third law. Third law is actually a part of chemistry pupil, but obviously I'm going to learn that. The entropy at 0 Kelvin. You will see this, leave it now. Reversible and irreversible process, entropy, change in entropy is obviously there, yeah. We have isothermal, that is constant temperature, adiabatic constant heat, isobaric, bar means pressure, okay, we have barometer from that bar, so that's pressure, unit of pressure. So isobaric, we have isochoric, that is volume processes. We have Otto and diesel engines. Okay, engineering people must know that. So we have Gibbs phase rule and chemical potential. Chemistry people study this in their course. When I had my chemistry general course and during my college days, I had gone through this topic in chemistry. I hadn't gone through this topic during my physics courses. So we'll learn this here obviously. We have van der Waals equation of state of a real gas with critical constants PC, VC, TC. Obviously A, B, such things, relation with them. So VC is equal to 3B, I think. Okay, we'll see that. We have Maxwell-Boltzmann distribution and molecular velocities, such graphs. टेम्परेचर, वेरिएशन ऑफ टेम्परेचर, ग्राफ क्या हो जाएगा, ऐसे क्वेश्चन आ सकता है. ना भी आए तो यू कैन यूज एज एन एक्सप्लेनेशन, राइट. सो नाउ वी हैव ट्रांसफर फिनोमेना, equipartition and virial theorem. Equipartition theorem and virial theorem, they are important. Now this is a part of solid state physics. Dulong Petting, Einstein, device theories of specific heat of solids. Okay, this is a part of solid state physics. So we can do it in solid state or we can do it here, and that we'll see in near future. Doesn't matter. They're easy things. Just you need to make an algorithm of the steps and you can easily write. इसका प्रॉब्लम क्या है आइंस्टाइन का, डीबाई ने कैसे वो कोप अप किया, हाउ डिड ही इम्प्रूव आइंस्टाइन्स लॉ. दिस थिंग्स आर इम्पॉर्टेंट. नाउ वी हैव Clausius-Clapeyron equation, adiabatic demagnetization, Joule-Kelvin effect. This is applicable in रियल गैस ओनली. ओके, जूल केल्विन इफेक्ट, ठंडा हो जाता है, गर्म हो जाता है गैस, कैसे, ये सब. लिक्विफिकेशन ऑफ गैस. नाउ वी हैव स्टैटिस्टिकल फिजिक्स, वन ऑफ माय फेवरेट पोर्शंस. मैक्रो एंड माइक्रो स्टेट्स, स्टैटिस्टिकल डिस्ट्रीब्यूशंस, मैक्सवेल-बोल्ट्जमैन MBB-FD डिस्ट्रीब्यूशंस. सो ये पोर्शन थोड़ा बच के पढ़ना है, क्योंकि अगर एडवांस फिजिक्स में हम चला जाए तो ये पोर्शन ख़त्म नहीं होगा कभी भी. ठीक है, दिस पोर्शंस विल नेवर एंड, सो वी नीड टू बी सेलेक्टिव व्हाइल स्टडिंग. विल सी इट एज पर द प्रीवियस ईयर पेपर्स. प्रीवियस ईयर पेपर्स आर जस्ट बाइबल, गीता, कुरान फॉर this UPSC exam. They are very important, but yeah, as you know, this is very unpredictable, so we'll see that, no issues. Micro and macro state, statistical distributions. We have application to specific heat of gases and black body radiation. Oh wow. And concept of negative temperature. This I will give you a simple note. You can read that. What is negative temperature? I have studied this in MSc only. We hadn't that in our BSc classes. So now you know NEP, new education policy, 4 years graduation. You'll get honors. I was going through the syllabus. You have some research project in BSc as well, so that's a good thing. But I think the MSc will be 1 year, right? You people might comment. I'm not sure about it. So let's see. We'll see that in 5 to 10 years, within a decade, how successful the NEP is. So let's see that. Now let's. कहाँ गया? 1 minute. This is paper 2. Sorry, I forgot to write the heading. This is paper 2. So first paper will be 150 marks. पकड़ के चल सकते हो कि CM and EMT, from CM and EMT will get 50% of the questions, and from rest of the part like thermo, no, so sorry, CM and ये waves oscillation optics ऐसे 50% आएगा, और thermo और EMT ग्रुप A रहेगा और एक ग्रुप B रहेगा. EMT इससे आपका 50% क्वेश्चन आएगा. ठीक है, ग्रुप B ऐसा होता है. ठीक है, बट दे कैन चेंज देयर ट्रेंड. सो बी रेडी. वी आर जस्ट गोइंग टू प्रिपेयर. क्वेश्चन क्या आएगा वो देख लेंगे एग्जाम हॉल में जाकर. ठीक है. नाउ वी हैव क्वांटम मैकेनिक्स. फॉर क्वांटम मैकेनिक्स वी हैव दिस इज पेपर 2 ऑब्वियसली 250 मार्क्स पार्ट ए. अच्छा ठीक है, पहले लेट अस डिस्कस. फर्स्ट वी हैव वेव पार्टिकल ड्युअलिटी, Schrodinger equation and expectation values, common. Uncertainty principle, very common thing. Solutions of one-dimensional Schrodinger equation of free particle. Gauss packet, particle in a box, particle in a finite well. Linear harmonic oscillator, reflection and transmission by a step potential by a rectangular barrier. Particle in a three-dimensional box, density of states, very important thing. Free electron theory of metals, angular momentum, hydrogen atoms, spin half particles, properties of Pauli spin matrices. So for mathematical portion I will suggest go through Oruldar's book. Oruldar's 500 solve. I have studied quantum mechanics problems from this book, and this is an excellent masterpiece book for me at least. I don't know if people will like it or not. For theory book you can prefer any book. You can go to J.T. Lee, A.C. Verma. Even you can read this Sir Oruldar's book, theory portion. There is another book. You can choose any book. Just you need to have mastery in the derivations. They are important for this exam. पार्टिकल इन अ बॉक्स का डेरिवेशन, वेव फंक्शन निकलना है, एनर्जी निकलना है, कैसे निकलेगा, रिफ्लेक्शन ट्रांसमिशन के लिए. ठीक है, दिस डेरिवेशंस आर वेरी इंपॉर्टेंट फॉर दिस एग्जाम. नाउ लेट्स गो टू द एटॉमिक एंड मॉलिक्यूलर फिजिक्स. दिस इज माय फेवरेट पोर्शन फॉर पर्सनल. सो फॉर दिस यू कैन गो थ्रू दैट आर राजकुमार बुक. For UPSC R Rajkumar is enough. अगर MSc for BSc I don't know what's the syllabus now. During our time the syllabus was actually, to be frank, very less, and as we had done in COVID period, you know, at that time we had online exams, and how much we people had studied. Okay, in online we all know what we had done in online exams. So go through Rajkumar, and there are some other books for MSc people. So your professors might suggest. It totally depends on the professor in case of MSc, what the book he or she is following. So follow that. So that advanced kind of knowledge is not required, that MSc kind of knowledge for atomic and molecular. So let's see what's the syllabus. So we have Stern-Gerlach experiment, angular momentum, spin तो रहेगा ही, इलेक्ट्रॉन स्पिन, फाइन स्ट्रक्चर ऑफ हाइड्रोजन एटम. वी हैव एलएस कपलिंग, जेजे कपलिंग, वेरी इंपॉर्टेंट. Ellis and J.J. coupling, spectroscopic notation of atomic states, Zeeman effect. UPSC will give you direct question, what is Zeeman effect? Explain it directly. You have to very good and very precise in your answer writing, and very good in the diagrams. Diagrams are very important for scoring high marks in physics. We have Frank Condon principle and applications. We have elementary theory of rotational, vibrational electronic spectra. This is molecular physics. Molecules. We have Raman's effect, molecular and molecular structure. We have now laser. So we have three parts here: atomic, molecular, and laser physics. For laser, laser we have already done, no? In the first paper also we have laser in modern optics. So let's see. We have laser Raman spectroscopy in importance of neutral hydrogen atom. So laser we don't need to do here. We are going to cover it in modern optics. So that's a good thing. Paper 2 is slightly lighter than paper 1. We have fluorescence and phosphorescence. I had done my master's project in this topics. Fluorescence, phosphorescence, FTIR. I leave it. Past is past. So molecular hydrogen ion in astronomy. I haven't done this part. Molecular hydrogen in astronomy. Elementary theory and applications of NMR and EPR. EPR हमारा एक experiment था lab में. NMR we haven't done. I haven't done it. We'll study this. Questions are easy. They will give you some. I'm telling gate questions. Leave it. What happens in gate or net? They give you 4 options. कि किसका NMR होगा, ऐसे देखना पड़ता है स्पिन वगैरह लेकर. I will leave it. So our target is this, no? I'm preparing this. I'm making this video for this exam, not those exams. We have elementary ideas about lamp shift and significance. So lamp shift is also mentioned in the book. A very short explanation is given. Such shifting of energy levels and all. We'll study it. So we have nuclear and particle physics. Some people will go to Tayal sir's book. Some people will suggest S.N. Ghoshal's book. And if you have some book, you can go through it. Though numericals are not so important for this part, but you know the unpredictability of the exam, some of the numericals might come, and as calculator is allowed, they might give good numericals from this portion. Okay, so first we have basic nuclear properties. We have size, binding energy, angular momentum, parity. This is the very first chapter of S.N. Ghoshal book. I will teach from S.N. Ghoshal, obviously. Semi-empirical mass formula and applications, very important. ये फॉर्मूला आप लोगों को याद रखना है. 5 चीज़ें हैं. पहले का प्लस होता है वॉल्यूम का, फिर सरफेस, एसिमेट्रिक, ऐसा होता है ना, पेयरिंग पढ़ा होगा आप लोगों ने. इफ़ यू हैव डन बैचलर डिग्री इन इट, यू हैव स्टडीड इट. यू हैव मास पैराबोलास, ग्राउंड स्टेट ऑफ अ ड्यूटेरॉन. वी हैव गॉन थ्रू दिस इन आवर MSc ओनली. हमारा टीचर पढ़ाता था, क्या पढ़ाता था आज भी मुझे नहीं समझ आया, बट उतना भी टफ नहीं है. आई एम नॉट गोइंग टू कॉम्प्लिकेट एनीथिंग इन दिस वीडियोस. आई कैन गिव यू एश्योरेंस. आफ्टर द वीडियो you'll understand the thing. I can give you assurance about that. Magnetic moment and non-central forces. Mason theory of nuclear forces. We have salient features of nuclear forces. Shell model of the nucleus, very important part. These models are important. This one, this semi-empirical formula, models of very important. Success and limitations. We can read a slight amount of the limitations like collective model. A violation of parity and beta decay, gamma decay, and internal conversion. Elementary ideas about Mossbauer effect. Spectroscopy. This is there at the last of the gamma decay chapter. Okay, we'll read this. You can go through A.C. Verma's video of nuclear physics. They are advanced, but if you're interested, you can go, or you can see my videos. Obviously, A.C. Verma is a legend. I have nothing in front of him. But okay, I can teach. Not a legend, but I can teach. Now we have Q value of nuclear reactions. We have nuclear fission and nuclear fusion. Energy production in stars. That reactions are very important. We have nuclear reactors. थोड़ा बड़ा है nuclear physics ना. We have classification. ये तो nuclear के वो हाँ nuclear. Up to this we have nuclear. Now we have classification of elementary particles and their interactions. Conservation laws, quark structure of hadrons, field quanta of electroweak and strong interaction, elementary ideas about unification of forces, and physics of neutrinos. We'll read everything in a simple manner. Obviously in our MSc classes I was just about to cry when our professor taught particle physics. Means why he is teaching, how and when. Though I have attended very less classes, but that doesn't matter. Who have attended all the classes had the same condition like me, so I don't know. So MSc is a little bit different game than BSc. It's much advanced than BSc. BSc people can tackling MSc is not that tough. My grade point is kind of okay, but feelings, this is the actual feeling. BSc, MSc, I don't have a great experience in MSc. Maybe it's the place where I have studied, or I don't know. I haven't enjoyed my MSc. I have enjoyed my BSc. it depends, right? So at last we have solid state physics, devices and electronics. Let's see what we have to need to study in solid state physics. We have crystalline and amorphous structure of matter. Common चीज़ है. Different crystal systems, space groups, method of determination of crystal structure. We have X-ray diffraction, scanning and transmission of electron microscope. We have band theory of solids, conductors, insulators and semiconductors. Thermal properties of solid, specific heat, Debye theory, magnetism, dia, para, ferro. Elements of superconductivity. Two types of superconductors we have, no? 1, 2. Their graphs are like this, something like this, something like this. Leave it. Josephson junctions and applications. This our professor had taught. We had a great professor. A very good professor. So उन्होंने अच्छा पढ़ाया था ये जोसेफन जंक्शन. I still remember. Read DC, AC. अच्छा पढ़ाया था. Elementary ideas about high temperature superconductivity. Okay. Now we have the electronics part, a very short portion. We have one part of semiconductors. Need two part, NPN and PNP and NPN. Now we have amplifiers and oscillators. We have op amps. Now these portions are also important. You don't need PhD in it, just we need to go through the working principle, WP. So you have digital electronics and the important portion, Boolean circuits, Boolean identities, De Morgan's law, A dot V, जानते हो आप लोग, A plus B dot V, easy things. Logic gates, truth tables, simple logic circuits, thermistor, solar cell, yeah, the principle might come, the diagrams, so हम ये देख लेंगे. Fundamental of microprocessors and digital computers. Yeah, I have done this in BSc, but कुछ समझ में नहीं आया था. क्वेश्चन आया था शायद और था, इसलिए बच गया था. सो पार्ट बी मैं इतना ज़्यादा बात नहीं करूँगा BSc और MSc का, बट चलता है. फर्स्ट वीडियो है मेरा इस चैनल में, सो व्हाई नॉट. एज नॉट दिस चैनल फॉर UPSC एग्जाम आई माइट से. सो 250 ग्रुप ए में रहेगा आपका पार्ट बी, मतलब पेपर बी. हाँ, पेपर 2 रहेगा आपका क्वांटम मैकेनिक्स. आई थिंक यू कैन अंडरस्टैंड माई हैंड राइटिंग. Actually, physics is a subject of numericals, so numericals mean mathematical expressions and all. So I don't think you people will get any problem for understanding my writing. So, atomic and molecular quantum mechanics. For group B, we have SSP इलेक्ट्रॉनिक्स, ये तो एक साथ ही आएगा, और न्यूक्लियर और पार्टिकल, ठीक है। अच्छा पोर्शन है, दोनों ही अच्छा पोर्शन है, हो जाएगा। सो दैट्स ऑल फॉर दिस लेक्चर। थैंक्स फॉर seeing my video. You can like, share and subscribe my channel. So thank you. We're going to meet in the next video. Let's see. So thank you. All the best for your examinations. All the best.